So we learned radian measure as pi radians equals 180 degrees. So that to convert degrees to radians by doing the following, we take the degree times pi over 180 to give you the radian measure. Okay, so we've spent plenty of time with examples, but today what I want to touch on is the geometry of this radian measure. So today's title will be Geometry of Radian Measure. So let's look at the geometry. We notice the circumference of the circle. Circumference is equals to. Alright, so I have some trouble with using my tablet with my camera, but since I don't think I need to show my face while doing this, so I'll just keep going, okay? Alright. So the circumference is pi times the diameter, so that if you have a diameter one circle, then the circumference will be about 3.14. That's something that you learned a long time ago, right? But in college math, we like to use radius over diameter, and the relationship between diameter is twice of the radius, so you end up with 2 pi times r, where 2r really is the diameter, okay? So that's the formula. Now, suppose you have, say, some angle theta degrees, and let's say our question is, what is the arc length? And to answer that question, you can take the 2 pi r, which is the entire circle, but then you multiply this by theta degrees divided by 360 degrees, because the full circle is 360, and theta degrees is your proportion. So you can kind of say that this much right here, this right here is proportion of the arc to the whole circle. Okay, so that's where I'm getting this formula from. Okay, so what? Well, you can now cancel the 2 pi r. See, 2 pi r theta degrees over 360 degrees. People are coming. Right. So you see 2, you can take the 2 and 360, and because both are divisible by 2, now this becomes 180. So you can now rewrite this in the following way. You can say it's like r times theta times pi divided by 180. So all I did was I canceled the 2 and the 360 to create 180, and I switched things around. Multiplication is commutative, so I can just switch things around. But then if you look at this, I noticed something. Hey, this is exactly the formula that we got for the radians. See, you take the degrees to radians by multiplying pi over 180. So we can say that the upshot, I guess that, I'll go back to black. So upshot is that if theta is already in radians, then the arc length S, we'll call this S. Okay, so this length right here, then arc length S is simply R times theta. And that's because you don't have to I forgot to check that the mic is on. Let me see, is the mic on? Okay, good. Yeah. All right, so see, if you measure theta in degrees, this ugly formula is how you find the arc length. But since this much is how you convert degrees to radians, if you have radians, you have a very simple formula, S equal to R times theta. And usually people write this as theta times R so that it looks like SOR, SOR. And let me try to. This is the formula, incorrectly referred as the read as SOR formula. Okay, incorrectly read as SOR formula. Okay, so I believe we had some trouble with our Outlook email system, so some of you must have gotten the email late. I did start the class 5 minutes late just to account for that, but I guess people are still coming in. All right, so for those of you who just came in, I kind of spent the first 10 minutes explaining this formula, but you can disregard everything. I'll send out the recorded video later so that you can see why that formula holds. But to understand all the lectures that happen afterwards, the only thing that you have to know from what you learned so far is the fact that if you have a circle, a full circle, and here's your radius, and let's say if this is your arc length S that you're trying to measure, the way you compute S is by using this SOR formula. You know how people who are lacking some more education tend to not know how to read Greek letters. This is called theta, right? And those of you who have never seen Greek letters may read this as O, thinking that it's a typo of O, but it's really theta. But let's just say we will just mispronounce, and this will be just SOR formula, SOR. And that works. It's easy way to remember that. And so the arc length formula is S equal to theta times R. But there's a catch. The catch is that theta must be in radians. If you don't have radians, then this doesn't work. So in fact, I kind of explained that radian measure is preferred over degrees in calculus because it makes the calculations easier. There's another faction of math where radians measure is easier than degrees, and it's when you have to convert these arc length formula when you talk about these. Well, let me give you an example. So let's say the very first question is convert 4,000 RPM to miles per hour if the wheel has diameter of, say, 2 feet. Okay. All right. So how do we do that? Well, so solution is first one revolution is 1 full circle, and full circles have 2 pi r as the formula, right? But because diameter is 2, we have radius as half of the diameter, which is 1. So using this, we can say this is equal to 2 pi in foot. Okay. Now, so let's see. So this is a case where you have some kind of a sports car that's going at a really fast speed and it's rotating 4,000 times per minute. So 4,000 rotations per minute. So RPM really means rotations or revolutions per minute. So if you have 4,000 revolutions per minute, that would be same as 2 pi times 4,000 feet per minute because of what we just computed. Okay, and you might wonder what this has anything to do with the formula that we just did. Actually, this 2 pi r is this formula that we just did, because a full circle has angle of 2 pi. Full circle, right? And therefore 2 pi is the angle times the radius r gives you the arc length of the full circle, which is the circumference. That's the way we are using it. Okay. All right. So in here, now what do we do? The problem is I have to convert feet per minute into miles per hour. So let's do that. For me, it's easier to write in terms of type this in. So okay, so we have 2 pi times 4,000 feet per minute. Okay, and let's use a calculator. That's a scientific calculator. Okay, and I forgot how many feet is in meters. So 1 foot in miles. Okay, so this is much miles it is. Okay, so maybe this should be given 5 to 80. So that's that. Okay, so since 5 to 80 feet is equal to 1 mile, we have 1 foot equals 1 over 5 to 80 miles. Okay, and since 60 minutes is equal to 1 hour, we have 1 minute equals to 1 over 60. 1 over 60 hours. Okay, so that allows us to convert what's given to us in terms of miles per minute, and the way we do it is we say this is equal to 2 pi, 4,000 times 2 pi, 4,000 times 2 is 8,000, so 8,000 pi times 1 over 5 to 80 miles divided by 1 over 60 hours. Okay, so I've converted the feet into 1 over 5 to 80 miles and minutes into 1 over 60 hours. I guess the font is a bit small. Sorry, let me make it bigger. That's easier. Okay, so now let's put everything in here into the calculator. So, where is it? Okay. So I have 8,000 times pi times 1 divided by 5 to 80, and then divided by 1 divided by 60. And if I do that, I get 285.6 miles per hour. So this sports car, that, what was the value again? 285.6. 285.6 miles per hour. Okay, so we can solve this question from RPM to linear velocity by multiplying by conversion factors and also using the 2 pi r. So I guess in general the formula is, in general, x RPM is going to be this. X RPM is going to be x times 2 pi times the radius, okay, and then per minute. Okay, and for this radius you have to include units, so that's how you do this. Let me give you a different example. Okay, all right, so a wagon is being pulled and its wheels are rotating. Let me make this bigger. Okay, at 200 RPM. Okay, if the wheel diameter is, say, you have a 10 inches, convert this, find find the wagon's speed in miles per hour. Okay, solution, let's try this. So 200 RPM is now going to be 2 pi times, 200 times 2 pi times R is 10 inches, right, per minute. Okay. Okay. So it's going to be equal to 20 times 200 is 4,000 pi inches per minute. Okay. But then now let's change things around. 1 inch is equal to 1/12 of the foot, right? But 1 foot, we just learned that it's 5 to 80 miles. 1/5 to 80 miles. So we have to convert 1 inch by doing this, and again, just as we did before, 1 minute is going to be 1/60 hours. Okay, so using these two, now we can say that this is equal to, the top can be replaced by this much, the bottom can be replaced by this much. Okay, so let's put that in. Okay, so we have this time 4,000 pi, but we also have 1/12 multiplied. Okay, and then this is 11.9 miles per hour. Okay. So yeah, I'll send out the PowerPoint slides, so don't worry about having to take all the notes. Okay. All right. So now let me try to talk about the area. That's another side of the geometry. So for the area of a circle, we know that the circle area with radius r is given by pi r squared. Right? Now what does that mean? That means if you have a central angle theta degrees, then the area of a sector this piece of the pizza pie that you have, is going to be equal to pi r squared, again by using proportion. The entire circle is 360 degrees, but your angle is theta degrees. The central angle is theta degrees. So you just use this proportion. And again, we use some kind of a trick. Say that 360 is 2 times 180. And then since pi times 180 times theta is theta in radians, that's how you convert pi over 180 times degrees gives you the radians. And then this is radians. So you can rewrite this as 1/2 times r theta. But wait, this is SOR. Theta times r is S. So you can rewrite this as 1/2 rs or 1/2 SR. So we get this formula A equals to 1/2 SR. And this is rather surprising because if you had a sector whose central angle is theta and this S is the length of the arc and this is R, this radius is R, then if you think about this length here, that's also R because radius is same, it's always congruent in a circle, right? And because radius is 90 degrees to the base, you can really read this as S is like the base of a triangle and R is like the height. So this is kind of like area equals to 1/2 base times height, where the height is like the radius R and base is S. Yeah, that's it's just a coincidence that it works. So don't think of this formula as like that's the reason. The reason is everything discussed here. That's the reason. But that's the formula, okay? So let me give you an example problem for that. Find the area of a sector below. Okay, and let's say you have here, say 70 degrees, and this is 8. The radius is 8. So how do you solve this? Well, first you have to convert 70 degrees into radians. So theta is 70 degrees converted into radians. Conversion factor is pi over 180 degrees. So degrees cancel and you get 7 pi over 18. Okay, and then use SOR, which says theta is 7 pi over 18 and radius is 8. Now you can reduce 8 and 18 because they're both multiples of 2. 8 is 2 times 4 and 18 is 9 times 2. And if you multiply 4 and 7, you get 28 pi over 9. And now you use the formula area is equal to 1/2 base times height, although you shouldn't say that. 1/2 S times R, that's the formula. And you have 1/2 times 28 pi over 9 times 8. Now 8 divided by 2 is 4, and 4 times 28 is 32. 112 pi over 9. So that's the answer. Now if the question is not given with any units and it's not a word problem, this is fine. But they might ask you to round off to the nearest inches or something. So let's just compute it to also get the approximate value. 112 pi divided by 9 is 39.1. If you approximate it, this is about 39.1. So if it was in inches, this will be square inches. Okay, so now let's move to a different topic. Now let's talk about equations of trigs. Not trigs, with trigs. Right. Okay, so here's a question. Solve, find x satisfies, say, 2 cosine of theta plus 1 equals 0 in the interval, let's say 0 to 2 pi. Now, the way you solve this, initially it's very similar to how you solve a linear equation, but then it becomes hard after that. So you can subtract 1 to the other side. You can divide by 2. Okay. And then you have cosine theta is -1/2. All right, so now you have to know when cosine theta is equal to -1/2. That's the tricky part. To do that, you have to remember the graph of the cosine. So let's go and draw the graph of cosine. Okay, so this is the graph of the cosine. From 0 to 2 pi. And what we are looking at here is, and by the way, yeah, I should also, if this was in classroom, I would actually draw it, right? 2 pi, pi. I try to drill this into your head. You always have to have these 4 points, and then cosine goes like this, right? And you're looking at the point where it gives you -1/2. But I wanted to show you a better picture, so here's a better picture. -1/2 is here, and you're looking for the place where it hits -1/2. Now the picture is detailed enough, and kindly enough it says those values are at 2 pi over 3 and 4 pi over 3, so the answer is 2 pi over 3 and 4 pi over 3. But how would you know this? Well, you know this by first knowing that, see, this is pi over 2, and right in the middle, this is the 45-degree family angle, and there's really 3 angles per quadrant, right? So this is from 90 degrees to 180 degrees. This is quadrant 2. And in each quadrant, there exists 3 special angles, right? And among those 3 special angles, you're looking for the short guy because 1/2 is small size. So remember we are talking about the 3 important values of sine and cosines. They all look like this, and it's very easy to remember. It's because it's like 1, 2, 3. And because square root of 1 is 1, this is what you're looking for. It's the small guy. And the small guy definitely resides here. So you know that out of the 30, 60, 91, it's the 30-degree one, but it begins at 90 degrees. So the way you figure out this angle is by doing 90 degrees plus 30 degrees, which is equal to 120 degrees. And then you just convert this to radians, and that's how you get this. Okay. Same thing here. Between pi and 3 pi over 2, the middle part is here, but then there's a before and after. There are special angles. Now you're in quadrant 3, and therefore you get 3 special values, and the small guy is right here. And out of the 30, 45, 60, this time it's the 60-degree guy that gives you the small. And since it starts from 180 degrees, so you do the other angle by 180 plus 60 degrees, which is 240 degrees, which is double of the 120 degrees. So that's why it's 4 pi over 3, because 4 pi over 3 is twice of 2 pi over 3. Okay, so this is how you solve an equation with trig functions. Let me give you another example for you to try. So I'll give you like 5 minutes to try a little bit, and then once you try, I'll try to show you how to solve it. Okay, I'll try to solve it, see if what I'm writing is similar to what you were thinking. Okay, so first let's make this bigger. First you move the 1 to the other side, and then you have to know that sine squared of x means sine of x squared. And actually that's a big part. If you didn't know that, you wouldn't be able to solve this question. Okay, and you can rewrite 4 sine. Actually you can now divide by 4, and you have sine of x squared as 1 over 4, which means that sine of x is equal to plus or minus square root of 1 over 4. And square root of 4 is 2. So plus minus square root. See, if you take the square root of a fraction, it ends up being square root of top and bottom separately. So that's going to give you plus minus 1 over 2. Okay, so this time I'll try not to use the computer graphics. I'll draw on my own. So here's 2 pi over 2, 3 pi over 2, and the graph goes like this, right? And you should know that in each of the quadrants there's always this middle guy, 45-degree one, and then there's one slightly before and after. Okay, and now because this one is the small guy, we're looking for the small length. So this one here is small, this one's small, this one's small, this one's small. Okay, now let's try to identify these by angles. So this one is out of the 30, 45, 60, it's the 30-degree one. So that's done. This one here is 30, 45, 60, and it's the 60-degree one, but added from the 90 degrees. So this one here would be 90 degrees plus 60 degrees, which is 150 degrees. This one here is 30 degrees, 45 degrees, 60 degrees, and here's 180 degrees. So if you add these two, it's 180 degrees plus 30 degrees, which is 210 degrees. And finally this one, you can do it the same way, but I also noticed that's right, like closer to 360, and this difference must be 30 degrees, right? So you can also do it like 360 degrees minus 30 degrees equal to 330 degrees. Now, you want to write these answers in radians because that's what will be asked. So let's convert this. So first of all, 30 degrees is 180 degrees divided by 6. And because 180 degrees is pi, you have pi over 6. 150 degrees is 5 times 30 degrees, so it'll be 5 pi over 6. 210 degrees is 7 times 30 degrees, so it'll be 7 pi over 6, because 30 degrees is pi over 6, right? And then, what is it? 330 degrees is 11 times 30 degrees, so it'll be 11 pi over 6. Therefore, the answer is all of those numbers, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Okay? Alright, so that probably was very hard for you, so I'll put a question that's very similar. Try this out. You really need to try these questions to learn. So my next question is try 8 cosine squared of x minus 4 equals to 0. Try this. I'll give you 4 more minutes. Okay, so let's try this one. I forgot to say, again, you want x to be between 0 to 2 pi. Usually I'll have this condition in. If it's not something different, then it becomes harder. but we'll not do those. Okay. All right. So solution, we would do 8 cosine squared of x equals to 4 divided by 8. You have 4 divided by 8, and that means you have cosine of x equals to plus minus square root of 8 divided by 8 is 1 over 2. So that's going to be plus or minus square root of 1 divided by square root of 2, which gives you plus minus 1 over square root of 2. But then this doesn't look like one of the special values, like 1 over 2, square root of 2 over 2, and square root of 3 over 2. Those don't seem to be, none of those three seem to be similar to what we see here until you rationalize the denominator. So that's why rationalizing the denominator is important. So let's try to rationalize the denominator here. You multiply radical 2 top and bottom to rationalize the denominator. And that gives you square root of 2 over 2, because square root of 2 squared. Maybe I'll write once. Maybe I'll just write it one more time. Okay, so that's what you get, and now you realize, oh, this is the medium size. So we're looking for the medium size in the graph. So let's go to the cosine graph. Well, let's just draw it. Keep trying to use the online one. No, I'll draw it. 2 pi over 2, 3 pi over 2, and then graph goes like this. And we have the middle guys here, and then some stuff like slightly before and after. But this is medium size, so we're really looking at the 45-degree one. So that means we have the 45, we have the 90 degrees plus 45, which is 135. We have the 180 degrees plus 45, which is 225. We have 270 plus 45, which is 315. And notice that 45 degrees is 180 degrees divided by 4, which is pi over 4. And 135 would be 3 times 45 degrees, which is 3 pi over 4. 225 is 5 times 45, so 5 pi over 4. 315 is this is 7 times 45, so 7 pi over 4. So these are the answers. Okay, so I'm going to conclude today's class by doing some super duper hard one. I'm not so sure if I can go this hard on the exam. Maybe, yeah. There's some exam questions that's probably similar. Exam practice problems that's probably similar to this one. Okay, so let's try this one. Again, let's find the x between 0 to 2 pi. The immediate first problem is that you see a mix of cosine and sine. So what you need to do is, and this is a key, so key is if cosine and sine are both present there, use cosine squared of x equals to 1 minus sine squared of x, or sine squared of x equals to 1 minus cosine squared of x. Okay, so that's going to be an important two kinds of formulas to use. They both come from this thing I explained, sine squared of x plus cosine squared of x equals to 1. You remember this triangle when I explained that if the hypotenuse is 1 and this is theta, this part becomes cosine theta, and then this part becomes sine theta. So that using Pythagorean theorem, you see that cosine squared theta plus sine squared theta is equal to 1. And if this is true, this should be true for any x, and now you can move, for example, if you take the sine of x and move it to the other side, you get the first equality. If you move the cosine squared of x to the other side, you get the second equality. Alright, so that's right off the bat, that's what you should do. Anytime you see sine and cosine mixed, you want to make it into a single function, only sines or only cosines, by applying these rules. So we're going to go ahead and take the cosine squared of x and replace cosine squared of x by 1 minus sine squared of x. Don't forget this parenthesis, very important. And then 6 gets multiplied. So that's going to be 6 minus 6 sine squared of x minus 3 sine of x minus 3 equal to 0. Now, 6 minus 3 is positive 3. And then I usually like the square to be positive, so let's multiply by -1 to switch the signs. 6 sine squared of x plus 3 sine x minus 3 equal to 0. And then I also notice that everything is divisible by 3, so let's divide everything by 3, which gives you 2 sine squared of x plus sine x minus 1 equal to 0. Okay, so this is really the equation that we are trying to solve. It still looks hard, right? Okay, so let me go to the next page. So forget everything that we've done before, just let's focus on this equation. How do we solve this? Well, see, sine squared of x, don't forget the convention that this is a shorthand for sine of x squared. I explained this last time. So if I take sine of x as u and do a change of variables, then this thing becomes 2 times u squared plus u minus 1. Okay? So if I set u as sine of x, the equation becomes a lot simpler. Okay, and that's the beauty of substitution. You can substitute a hard-looking equation and make it look simple just by doing substitution. And notice that we couldn't do this before if we had a mix of cosine and sine. then we can't just say u equals sine x, then we wouldn't know what to do with the cosine, right? So that was why it was necessary to use this first formula to change everything to just sine. Okay, so you have this, and now let's try to factor this. We could do like the AC method. Let's do the AC method. The AC method says we multiply the very first and the last, which is -2. There's a 1 that's hiding in the front. So 1 is here, and we're looking for two numbers whose product is -2 and adds up to 1. What are those two numbers? Those are, I see, it's 2 and -1. 2 times -1 gives you -2. 2 plus -1 gives you 1. So that tells us that we can rewrite 2u squared plus u minus 1 as 2u squared plus 2u minus u minus 1. And now we factor by grouping. So we group the first two together by 2, factor the first two together by 2u, factor the 2u out, and you get u plus 1. And anytime you have a minus, you should always factor that out, so it's minus u plus 1. That gives you 2u minus 1 times u plus 1. Now, because you're saying this should equal to 0, now you can set each one of them as equal to 0, which gives you u as 1/2. This will be u equals to -1. Okay. So we got the answer, but not yet. That's the downside. It's easy to fool yourself that you have an answer, but these are not the answers yet, because u is sine of x, so you're really trying to solve sine of x equals to 1/2, and sine of x equals to -1. When does that happen? Well, let's draw the sine graph here. Here's the sine graph. Remember that we have 3 sticks in each quadrant. 3 sticks. Draw the 3 sticks. And since 1/2 is the small guy, we're looking for the small guy. It's here and here. Now this is small too, but that doesn't count because it's negative. We're only looking for the positive one, right? So when you're looking for the positive one, it's only these two. And we see that it's 30 degrees, which is pi over 6. And the other one is at 150 degrees, which is 5 pi over 6. I'm going to skip the way you figure these out because we've done many in the previous one. Now how about sine x equals to -1? It happens right here, which is, no, not there. Right here at 3 pi over 2. So x is equal to 3 pi over 2. And therefore the answers are these, and this one will be the answer. Okay, so that was a tough one. Yeah, please try the practice problems. You'll see some questions like this. All right, that's all for today. Thank you everyone for joining.